This event is recorded, and I'm planning to publish it to YouTube for anyone want to see it again. So if anyone objects, please find me. You can use the meetup.com platform, or you can use any of these Twitter. This is Twitter. I don't know why. It's writing now. This is Twitter or GitHub or anything. Try to find me, and we will sort things out. We'll blur you out or do anything, something. I don't know. So today we have, as I already said, a very interesting event, a very interesting talk by Steve Gordon. I think everybody knows Steve anyway. It would be, I'm always curious to find out about internal things, how things work, and this is all about. I believe that when this is done, we will all be able to write much more optimized code than we were doing because we know the internals, right? So Steve, although you most probably know him, he's a Microsoft MVP and Pluralsight author. I've seen quite a few of his Pluralsight videos. And actually, I think it's quite common for everyone that while Googling for stuff, while Googling for a question, he sort of most probably end up in his blog for answers. So yeah, Steve, very happy to have you here. I'm very glad and very honored. The virtual stage is yours.
Thank you very much. Can you hear me okay? That's the most important question. Good.
Yep.
Okay. I need you to stop sharing, please, and I'll try and share my screen here.
I will stop sharing right now.
Okay. Give me 2 seconds. It's always a little bit more fun doing this remote because you've got so many windows. Hopefully, people can see slides. So as long as you can hear me and see me, we're going to be good. Okay, well, thank you very much, George. Thank you for inviting me to this event. First one of 2021 for me. And it seems like it was, by date, it was quite a while ago that we discussed me doing this, but time seems to be going really quickly during the pandemic. So it's kind of rushed up on me. And I'm really excited to kind of give this session again. So yeah, if you don't already sort of follow me on Twitter, you can find me there at Steve J. Gordon. So if you have any questions that kind of come to mind after the event and you want to reach out, please do. DMs are open there. I'm reasonably good at getting back to them. I try and keep an eye on them. And so, yeah, happy to try and follow up there. And as George mentioned, a lot of what I'm going to cover has been touched on in some form or another through my blog posts at stevejgordon.co.uk. I do plan to write some more actually based on this talk a little bit more specifically as well. So keep an eye out there. You can sign up for notifications when new posts come out if you want to. Probably the most important link on this slide deck, is the bit.ly link there. So bit.ly/ASP.NET Anatomy. This link will take you to all of the resources for the session. So if you want to view the slides after the event, there's a version of the slides there, and also the link to the GitHub repo where the code lives. So that's always useful to people. I know it's easy to kind of miss that link, so I'll call it out again at the end as well. And yeah, just a little about me. I'm a Microsoft MVP, AWS hero, and Pluralsight author. I work for Elastic. I joined them in November, so I'm working on maintaining the Elasticsearch.NET client. So really exciting kind of new role for me, really looking forward to kind of getting into that a bit deeper, looking at doing sort of performance optimizations and things there as well. So should be a lot of fun. But tonight I'm going to talk about another kind of favorite topic of mine, which is ASP.NET Core. And this session was designed really because I've had a number of questions over the years from people about, how can I manipulate ASP.NET Core to configure it in certain ways for certain very specific situations? And so in order to kind of answer those most fully, I kind of dove through the source code and looked at how ASP.NET Core actually works from kind of start to finish. I haven't read all of the source code, but I've read good chunks of it. And so what this talk tries to do is kind of explain a little bit about how ASP.NET Core actually handles your requests as they go through internally. So we'll actually basically follow one request through ASP.NET Core and back out again. And the goal of that is so that you can understand when and how you might want to override some of the defaults of ASP.NET Core or plug into some of its kind of plug-in points in order to be able to kind of apply your own cross-cutting concerns in your application. So that's kind of the objective. I've got the chat open on a second screen here. I'll try and remember to keep an eye on it. So if there's questions as we go through, I'm happy to try and kind of dive into them, or we can save them to the end, whatever people prefer. I'm happy to kind of try and do it. So yeah, put your questions there. If I see them, I'll try and pick them up as we go along, or a good point to do that. So let's dive in. What we're going to do is imagine that we're running an API. So let's pretend I've got an API up here on my blog's URL. And what we're going to do is assume that we're going to make a client request to that API to get some of the data from there. So assuming this is running ASP.NET Core, I mean, a lot of what I'm going to cover now is probably most applicable to 3.1 and 5 of ASP.NET Core, but a lot of the internals haven't changed all that much if you're running an older version. And so the first important thing is, you know, what's a client? I think we're probably all familiar with what a client is, but it's good to sort of remember that there's various forms of clients. So we could be talking about a browser that's making a request, not so often to APIs, I'll admit, but you could use a browser as a client into this API, or a third-party tool. So maybe, as we'll look at when we're doing some of the demos, Postman is a tool that is often used for accessing APIs, or it might be client applications of your own where you're using .NET and the HTTP client in .NET to actually make the request. And that's also very common and growing as we kind of start to evolve microservice architectures and things like that. So I have a whole talk about HTTP client and making requests that you can find online, or maybe, you know, some point in the future we can always do it for this event as well. This session will be sort of what's the other half of that. So what's it look like when that request comes through? So we won't go deep into these first few areas, but it's worth just kind of touching on them just so that we've got a complete picture. Of course, the client at this stage knows that it wants to talk to stevejgordon.co.uk. The first thing it's going to need to do is work out what server it can actually communicate with. So basically, we're going to involve DNS in this. If the client doesn't already have a cached record for this domain, it's going to have to go out to some DNS resolvers, which will refer it off to more and more specific DNS servers over the internet, depending on where the cache for this domain lives. And eventually, it may even end up on the authoritative domain server, which knows actually this website, this domain is hosted on an IP address. And this IP address, for example, could be that one there. So now the client has done this DNS lookup. And if you're using HTTP client or something like that in .NET code, this will be, you know, automatic. It's behind the scenes. You don't have to worry about all of that. But this happens first, and then we're going to need an actual connection. So HTTP is an application layer protocol. It sits on top of TCP for a reliable sort of packet exchange mechanism. And so the first thing we need is a TCP connection between client and server. So in this case, let's assume the client picks 64,000 randomly as an outbound port. It's going to try and connect to the IP address that we've been given by DNS. Typically on either port 80 or 443. Obviously, you can configure that. We'll assume that we're going to go over 443 and we'll have a secure connection in this scenario. So the TCP handshake takes place. It's not too important to understand the mechanics, but just bear in mind that there is overhead to any HTTP connection. If you haven't already got a connection with the server, we first need to establish one. And because we've decided we're going to use TLS, this is a good practice today on the internet, of course, we're going to use TLS sort of as an encryption layer and a security layer on the top of our TCP connection. And so we're going to have another handshake that takes place. And this is where the client can establish with the server, is it the actual server they think it is? You know, does it have a valid certificate to prove who it is? And also, what key exchange do we need to do? So, you know, what cipher suite are we going to use, and what keys are we going to use as we establish this? And again, there's some overhead to that process as well. So we've now established a connection. The next thing we're going to do is send the request. And for this part of the sort of talk, I like to actually go into what a request looks like, because I have come across developers that, you know, work day in, day out on the web, they're building server applications or they're talking to server applications over HTTP, but maybe they've never really looked at what a request looks like, because we're quite fortunate in .NET. We've got a fairly good abstraction over what a request and response looks like with HTTP client used to send those. We have the HTTP request message and the response message. But under the hood, the spec for this is pretty simple. And if you want to go and read the RFC, 7230 in the RFCs is the one that refers to the kind of syntax and routing of HTTP 1.1 requests. And I do urge people that are working with the web often maybe to go and check those out and have a bit of a feel. You don't need to internalize it completely, but have a bit of a feel for what's going on. It can really help when you have an unusual problem to understand where that might be at the very low levels as well. So in this scenario, we've basically got a set of ASCII text here, US ASCII text that we're going to be sending over the wire. So it starts with a request line. We have the get there indicating the HTTP method we want to use. So we're going to, in this case, request a resource. We're not expecting to change anything on the server. The resource that we want is /API/books, and we've requested to the server that we'd like to use HTTP 1.1. HTTP 2 is definitely picking up in popularity out there. More and more servers support it. ASP.NET Core supports HTTP 2 as well if clients want to use that. And HTTP 3 or Quick is also, I think, in sort of preview features of ASP.NET Core as well, if you want to go all the way to the latest stuff. But we'll use 1.1 just because it's an easier syntax to kind of follow. So we have this request line and then a carriage return. And then we can have a set of headers. So the key header that we want is the host header. This indicates, the actual host name of the server that we want to, or the site that we want to communicate with. And this will be used possibly all the way through the routing layers, through proxy servers as it gets its way over to the actual, the web server or the service in Azure or AWS that's running our website. We have some optional headers, so accept headers to indicate we'd prefer JSON, but we could fall back to plain text if they can't provide that, or anything else as a plan B. What language we prefer, which encodings we can support, so Brotli, gzip, deflate, compression are all things that we can accept as a client. And then we have a user agent, and this is quite important. I call this out in my talk about HTTP. If you are making requests, always include a useful and valid user agent on your request, because at some point in the future it will be really useful to you. If you own both ends of the story in particular, you'll be able to use this user agent as a way of tracking what clients are actually connecting with your APIs and things like that. So as a service, as a server, it's really useful to get these because you can kind of see who's calling you, and as a client it's useful if you make sure you've got updated and correct user agents. That will help with diagnostics if you have problems, and we've used this in production in my old job, where as a server, we were able to identify that we suddenly had an increase in 400 errors that we were returning. We actually saw that it was due to a change in the version of a client that was calling us, and we could see that in our logs quite clearly. And we were able to call them and say, actually, your client has recently upgraded from version X to version Y, and we think you've broken something because we're now seeing some badly formed requests coming from you. So that's why that stuff's useful. This is a GET request, so we don't have anything else we want to include, so we'll just end the request with an empty new line there. So this request is going to go over to that IP address, over the TCP connection that we've established, and make its way to Kestrel. Kestrel is the web server in ASP.NET Core. It was created at the time of ASP.NET Core 1.0 and has been there ever since. And it's started as, an in-process server that you kind of had to run behind a reverse proxy for security reasons in the kind of 1.0 days. And it's really matured now to, a proper web server. You can run this on the edge if you need to. Typically, you'll probably still run it behind some kind of reverse proxy system, but it's secure and it's incredibly fast. Kestrel is pure C# code, so it's written in managed code and it's designed to work cross-platform, and it spins up as part of your ASP.NET Core application. So internally, an ASP.NET Core application is really just a console app today. It spins up a host, and that host keeps the application alive. And as one of those things inside the hosting framework, you can register an iServer that's going to bind to some ports and do some work. And in this case, that server is Kestrel. So this has been extremely optimized in Each version of ASP.NET Core Kestrel has got faster and faster. Optimizations like, reuse of buffers and object pooling, dealing with making sure that they're parsing request parameters in a very efficient way, optimizing for things like known headers and particular bytes that they're looking for those kind of things have allowed them to get very quick and very efficient and have very low footprint. And so this is very well ranked now in the Tech and Power benchmarks. If you compare Kestrel to the other sort of fully fledged web servers that are out there, it ranks very near the top of those benchmarks. So it's very competitive to be using that today. And you can run this, as I say, as a plain console app with its kind of self-hosted mode, or behind IIS, or behind some other reverse proxy. So we have the request coming in from the client. It's traveling over the internet, over HTTPS. And we're going to Kestrel, which is accepting our connection. And then from there on, we'll be handling requests. As part of that connection exception process, then it passes the connection through a series of connection middleware. And if you're familiar with ASP.NET Core middleware, this is pretty much the same idea. It's a series of components registered in a particular order that each have an opportunity to deal with that connection as it comes through. And so things like TLS is actually implemented as connection middleware inside Kestrel. The reason I call it out is, although I've never needed to do this personally, it is possible to write your own connection middleware. If you have a very low level connection level requirement that you want to kind of intercept and deal with in a particular way, you could do that with your own connection middleware. But more often than not, the final kind of terminal piece of connection middleware will be the HTTP application, which is ASP.NET Core fundamentally. So that will get the request passed through to it by Kestrel once it's received. So we'll zoom in on that and see what actually happens a little bit more specifically. So Kestrel receives a series of bytes over the connection that it's got, and its job is fundamentally to parse those bytes into a valid HTTP request message. So it needs to, check that it's got a well-formed series of bytes that conform to the RFC. Can it parse out the method? Can it parse out this resource that we're asking for? All of that information. And the way Kestrel does this at the high level is with what's known as the iFeature collection. And this collection includes a bunch of information as this sort of set of bytes passes through the request handling of Kestrel. So it will include things like a connection feature, which includes details about the actual connection. So what port is being used on the client and what connection details that they specified. Any specific connection information can be found in there. There's also a feature around the request itself. So, the method, the request body, if it's present, all of that kind of information is at this kind of iFeature collection level. More often than not, that is something you don't really see because this is converted into the HTTP context. So the HTTP context essentially wraps that feature collection and provides the kind of application level abstraction over the request that we typically see when we're working with ASP.NET Core. So on that context, we have access to the request, but we also have access to some of that other information. We could interpret and pass our way through the feature collection to find other information if we really needed it. And the context also includes the possibility of storing the response, which will be later used to return the response back. So this context is created and then passed into the application code into that HTTP application implementation, which is kind of ASP.NET Core. So zooming in a little further yet again, after we have our context, before it flows through to what we'll sort of know as MVC, it has to go through middleware. And hopefully, as I say, many of you that have worked with ASP.NET Core will have already used middleware. Perhaps you saw it in its OWIN days as well. Middleware is simply a series of components that can handle the request as it flows through and handle the response on the way back out. And these are registered in your application at startup, and they're registered in whatever order you want them to be, but order will matter because once registered, they're always executing that order for each request as it comes through. And with these middleware components, they have basically three options. They can pass the request on without doing anything, and that then passes it on to the next piece of middleware. They can potentially modify the request or something on the HTTP context and then pass it on. Or they might choose to actually produce a response by setting the response on the HTTP context and actually short circuit the rest of the pipeline and skip all of the remaining middleware components. So these are the kind of key options that middleware has. And its job is to kind of marshal this request through to the point that we can eventually get it to something that will be able to produce a response. Typically, that's going to be some kind of endpoint or maybe ASP.NET Core MVC in your application code. Of course, once that produces a response, then it does flow back out through the middleware. And I'm going to reiterate this point a couple of times because it is important. It will flow back through the middleware pipeline, but this time in reverse order. So anything that was registered last in your pipeline will be last to see the request come through, but first to see the response go out. And this gives us a kind of final opportunity. Those middleware components may maybe do some kind of logging based on what they see in the response. They may modify the response. They may just do nothing and continue passing it back up the chain. But they have those kind of opportunities. And this is typically where you want to implement any cross-cutting concerns you have for your application. So registering middleware is done in the configure method of the startup class. Again, hopefully many of you have seen this. The configure method accepts an iApplication builder. It can accept iWeb host environment and iConfiguration as well. And these things can be used to determine what our pipeline is going to be. So configure gets called when the host framework starts up ASP.NET Core. This pipeline is going to get built at that stage based on what's in this configure method. And so, for example, here we have our first piece of middleware being registered, which is the developer exception page middleware. And that's done with this extension method. And this is something and a good example really of where you might want to register middleware conditionally. So we don't want this middleware to be available in production because it would actually leak out stack traces and things if you have an exception in your application. And what we can do is say, well, if when this application starts up, the environment is development, then yes, we will register it in the pipeline. Otherwise, it won't be part of the pipeline at all. And you could do a very similar thing with iConfiguration. I've just seen the first question actually, which I missed from Trime. So this is it updated in regards to .NET 5? So this talk. I have updated a few areas. I haven't gone through everything, but pretty much everything I'm going to cover is applicable from pretty much 2.1 onwards. Certainly from 2.2 onwards, actually, in terms of the feature set, and pretty much remains unchanged for the purpose of this session, at least. The next piece of middleware then in this pipeline is HTTPS redirection. This is a really good example of one that could potentially short circuit the request pipeline. If a request comes in and the scheme is HTTP, it's the job of this middleware to return a response to the client that's basically a redirect response that says, no, you need to be using HTTPS here. And so that's one that if that scheme is HTTP, it won't even pass the request on to the remaining middleware in this list. It will just return a response when the request comes in. Or if it's HTTPS, it just passes it on unchanged. So that's a conditional piece of middleware. I'm going to flip the diagram, and instead of looking at it in code, let's look at it as a kind of sequence diagram across here. So on the left, the request is coming in from ASP.NET Core. The pipeline gets invoked on the HTTP application, and then it passes through each of our middleware components. Now, one thing you might notice if you're reading this carefully is that there's two pieces of middleware in this list that weren't in the configure method. So where have these come from? There is one other mechanism for registering middleware. It's slightly less common and certainly not something I would recommend for probably 95, 99% of cases. But there's a concept of an iStartup filter in ASP.NET Core, and you can register those with the web host, and all of those filters will then get executed before building the rest of the middleware pipeline. And those startup filters have the opportunity to inject middleware very early in the pipeline in such a way that they can't be modified in code later on by changing the startup class. The reason they're done for these two is these are kind of key critical pieces of middleware that the ASP.NET Core team want to enforce at the start of the pipeline. There are rare cases where you might have something similar. The one where I've come across potentially using this is if I had a piece of kind of logging middleware that tracks some metrics about the request as soon as it comes in and then wants to write them out to some metric system on the way out. It's good to run that early, and it can be convenient maybe to register that in a way that it can't accidentally be removed. But for most people, I recommend that you use the startup class because it's a lot more discoverable. If people are trying to work out how the application works and why requests might suddenly be returning a different kind of response to what they were expecting, if they go to the startup class, they can see what middleware might be involved. They can dive into that and navigate to it. Using startup filters is a little less discoverable. The two here, host filtering is about if you've enabled it by setting it in the app settings JSON, you can determine which hosts your application should actually respond for. By default, it's just wildcarded out. And the host filtering middleware is what checks that configuration, sees if the host name on the request matches, and if it doesn't, then it will reject it at this stage. Forwarded headers is about typically handling proxy headers, so sort of X forwarded for and those kind of things, and mapping them down to headers that the rest of the framework will probably be checking the things. So those are registered in that special way. The rest of them are registered via the configure method of the startup class. And obviously, after an endpoint eventually builds a response and adds it onto the HTTP context, again, remember that that response flows back through this middleware now in reverse order. To create middleware, there's a few ways you might want to do it. This is an example of doing middleware inline. So we're using app.use here. And this takes this async lambda that basically has access to the HTTP context and a representation of the next delegate, the delegate being the next piece of middleware that's going to get called after us. So inside this particular example, what we're doing is we're starting a stopwatch, then we're making a request by passing on to the next piece of middleware. So we're just kind of awaiting the next delegate. And then as soon as that responds to us, we're stopping the stopwatch. So in that await next, it's going to the request is flowing through the rest of the middleware pipeline to whatever handles and produces a response, flowing back through anything else that's registered after us until it reaches us at this point where we get the item back. So here we're stopping the stopwatch, and what we're going to do is a very sort of low tech, not necessarily production ready way of logging a metric about this. So what we're doing here is we're reaching into the context, into its request services, which is the IS service provider in ASP.NET Core, and we're calling get required service to access the iMetric recorder. So this is kind of service location. It's not locator pattern. It's not very nice, but we have the recorder, and then we're just recording a metric with what was the status code of this request and how long did it take through the pipeline. So very low tech monitoring. We can improve this if we look at moving it over to a middleware class. So this is a regular C# class. You'll note it doesn't implement any interface. It's all done via kind of duck typing. So there is a particular sort of set of signatures that it's looking for to be a valid piece of middleware. And the key thing on the constructor is that we accept a request delegate, which is that next piece of middleware that we're going to be calling. But here we can also inject services. So we've injected an iMetric recorder, which is much better than doing kind of service locator pattern. Anything that you inject into this constructor, you must remember, is going to be essentially a singleton in your application, because these middleware classes are instantiated once when the application builds the pipeline, and thereafter anything that we capture in this constructor is going to live for the lifetime of the application. The other thing that middleware classes must have is either an invoke or an invoke async method. We're using async here because async is best all the way through if we can. So this accepts the HTTP context, returns the task, and in here, we're just doing the same logic we did before to start the stopwatch, call the next middleware, await that, and then stop the stopwatch and send our response to the metric service. If we have any dependencies inside middleware that we need to resolve either scoped or transient, so per request, you can inject them into invoke async. And ASP.NET Core is clever enough that it calls this method in a particular way such that it can inject the appropriate services from the request scope. So you can use shorter lived services inside this method if you pass them in as arguments. So to use the middleware, we just call app.useMiddleware on our configure method, so on the application builder, and we provide it the type. If you want to clean this up a little further, which is particularly important if you're maybe doing a library that you're going to share with others, a common pattern is to build an extension method on iApplication Builder. In there, it can call use middleware. It could register one piece of middleware or many, but basically it then just returns the application builder back out. So now we have this nice, simple method called use metrics. We call that on the iApplication Builder, and we have our middleware registered. And this is just how the ASP.NET Core default middleware is working. So the next thing I want to touch on is endpoint routing. And the reason this is important is it was actually introduced in, excuse me, I saw the windows in my screen here. It was introduced in ASP.NET Core 2.2, but it's been made a first-class citizen really since 3.0. So if you're on kind of the latest 3.1, endpoint routing was the preferred way of doing routing in ASP.NET Core today. Previous to endpoint routing, what happened was routing was done inside MVC, basically. So MVC was handed off the request, and then at that point, it would know all of the controllers and actions and what routes mapped to them, and it would handle kind of orchestrating and sending that request to the appropriate endpoint. The reason that was problematic, or is problematic really, is that it means that only MVC knows about where this request is going to end up. And it means that middleware is quite dumb, because middleware can only really work on what it knows about the request, not what it knows about where it's going. And that's why endpoint routing was brought up out of MVC into a first class part of ASP.NET Core and can be used kind of separately. And what this means is routing now is done at an earlier stage in the application flow by higher level components. And you'll see this kind of approach, I think, continue into ASP.NET Core 6 and beyond. The team are looking at more and more of these kind of MVC specific components and seeing if they function outside of MVC and have a purpose outside of MVC, should they lift them out of MVC's kind of namespaces and make them their own libraries. And that's exactly what the team kind of plan to do. So the way endpoint routing works is we have two key pieces of middleware. There's use routing, and this piece of middleware is about, as the request comes through, when it flows through this middleware, the middleware's job is to match the request to an endpoint. And by that, I mean it looks at its route table, which is created when the application starts up, although it can be refreshed when the application is running. And that route table contains all of the known endpoints in our application. So what methods and paths map to what endpoints, basically. But it has a bunch of metadata about those. So at this stage, it looks at the request and says, okay, so is this a GET request? It's going to this path. Okay, I know which endpoint's going to deal with that. It doesn't call the endpoint yet. What it does is attach that information onto the HTTP context. Later, use endpoints is the piece of middleware which actually invokes the endpoint. And so this is kind of critical in the ordering. A point of confusion here is this delegate code inside use endpoints. It looks like that might then happen later in the kind of request pipeline, but actually this piece of code, so this delegate here, runs when the application starts in order to build the route table. And in this case, what we're saying to it is map all of the controllers. So scan this assembly, find all of the controllers, find all of the action methods on those controllers, what routing maps to them, either the default route conventions or attribute routes, what maps to those, and build up a table so we know what routes we have in our application code. So that runs when the app starts, but then use routing and use endpoints as middleware run when the application handles requests. And so between these two, we're kind of in the routing zone of the application. And what this means is these other pieces of middleware here are what we call endpoint aware. And this is quite useful because now we have knowledge of endpoints outside of MVC. It means middleware can use that knowledge to actually determine what it should do. And so because of that, authorization, which was another MVC internal feature previously, has now been made its own separate piece of middleware. And this is the preferred way of applying authorization. So authentication middleware runs to map a claims principle off of the request coming in, and use authorization will see what the endpoint is that's eventually going to be called, look at its metadata, and determine based on that metadata, does it have maybe an authorized attribute? And if so, what are the rules for that authorized attribute? And does it require certain claims or roles? And then does the claims principle have those? And if it doesn't, it can return a forbidden response at this stage, rather than even passing it into MVC. So this is one of the advantages of bringing that earlier in the pipeline. This is all probably easier to see if we start getting into some actual demos. So I'm going to just stop that presentation, and hopefully we've got the code coming up for you all here. If the font size isn't big enough, scream out to me, but I'm hoping it's reasonable. So my application here is, this is the one that's available on GitHub if you want to take a look at it, and I've commented it fairly heavily. The piece we're going to look at for now is we've got use middleware calling this endpoint logging middleware here on line 78. And then I've registered that same piece of middleware, but a second instance of it here on line 83. And between that, we have this call to use routing. So remember, this maps the requests to whatever endpoint they're going to end up on. And so what this means is when it's called here, we expect this middleware to be able to be endpoint aware because it's in this routing zone. but when it's first called on that first instance, it won't be. And to just look at the middleware, it's not very exciting, but what we do is on the context, we call this new method get endpoint. That returns to us an endpoint if one is available. So if use routing has run, it will attach an endpoint if it's matched one. It's possible it hasn't matched an endpoint at all, in which case it will still be null. And then in this code, I'm just switching based on that and printing out some information about the request. That's not too important. So if I come over and make a request now to one of my endpoints using Postman, we'll see the request come in. And this is the first registered instance of that middleware. So this is the one before use routing. And you'll see here endpoint is null. So we have no ability to do anything with this request based on where it's going, only the properties of the request itself. But if I F5, the request has now flowed through use routing and come back into our second registered instance of our middleware. And this time I do have an endpoint, and we can inspect that endpoint and see, okay, it's got a display name that tells me this is going to be an endpoint that maps to a controller and an action method. And critically, we have this metadata, so a big collection of items that we know about this endpoint. And so in this case, MVC has attached all of the attributes that are applied via the hierarchy. So either to the controller class or to the action method specifically that applies to this endpoint. And we can use that information to determine maybe what we do with this request. And I'm just going to continue there and let that flow through. So the request has come in. So that's where that information can be accessed. And if you're writing middleware that needs to know something about where this request is going, that's kind of the way that you can do that. So we spent a lot of time just getting to the point where we're entering MVC world. And this is where we're going to really start digging into a bit more of the internals. So quick refresher for people that haven't used MVC in a while, or perhaps at all. MVC is the model view controller pattern implemented in ASP.NET Core. It's been around for a long time. You can use it for views and view-based applications that return sort of HTML. If you're building APIs, this will be fairly common as well. And basically, we have a controller and action methods which represent endpoints in our application. So here we have a books controller. It derives from controller base, and that's going to provide us a bunch of sort of key behaviors from that base class. It has a couple of attributes. It has API controller, which is optional, but provides a bunch of kind of default behaviors that the ASP.NET team have identified are common to APIs. One of the most common of those will be automatically returning a 400 error if the incoming request can't be model bound to the request properties. So you used to have to check that yourself and then return a 400 if you were, had a failure. Now that's done for you by convention by some of the mechanisms that we're going to look at in a moment. The other attribute identifies what root we want to use. In this case, we're saying we're just going to use the controller's name without the controller's suffix. So anything to /books roots into here. We can inject dependencies, of course, and then we have action methods. And an action method is any public method that returns an iAction result or something that can cast into an iAction result. So in this case, our get method here takes no parameters. It returns an action result, which is an IEnumerable of my output model. And we've identified that this method should handle get requests only. So by putting that HTTP get attribute on it, ASP.NET Core is only going to map this in its root table for anything that comes in with the get HTTP method. So basically what this means is this method gets called for /books because we haven't added any additional root attribute onto here. It's just going to take the root path of the controller there. And it's going to return some books. So at our 10,000 foot view, what's going to happen next is MVC is going to do a number of things. So the high level view is first, it's going to need to create an instance of the controller. And it does that using the controller factory to instantiate an instance of the controller per request. Once it's got an instance of the controller, its job is to then try and marshal that request into the action method that represents our endpoint. So that happens through a process where the controller action invoker is going to try and provide all of the required arguments of our action method and then invoke it. The result of that method is going to be this iAction result. So that's a representation of a result, not an actual result at this stage. So it indicates, high level things like, did it succeed or fail? Does it carry an object, which means it might need to return a body? All of that kind of information is kind of at that abstraction, but it hasn't yet turned it into HTML or the returned sort of response bytes. What happens is that iAction result gets executed as a final phase in the MVC pipeline. And if it's an API, it's just going to return a data result. So basically what's going to happen is the body, if there is one, is going to get serialized, attached to the response on the HTTP context, and then that gets passed back through. MVC with views, we're not really going to touch on, but there's an extra step in there to render the view. So basically it takes your output model and your Razor file, combines them together to figure out, what the final file should look like, and then builds from there rendered HTML and returns a response. All of this happens inside the MVC filter pipeline. And this is the stuff that we're going to spend the kind of final bit of this session talking about. So on the left, we have our middleware. So requests are still coming in left to right in this diagram. So the first filter that gets run, or type of filter, I should say, is authorization filters. Now, these are somewhat legacy since endpoint routing became a thing. So if you're using 3.1 and you're using endpoint routing, these will run, but they're basically no-op. It will check if use routing has already been called and use authorization has already been called. And if it has, it knows that authorization has been run as middleware and it no longer needs to apply that step. But for legacy applications where you're using the traditional kind of MVC routing, at this point, it's the first stage it would actually be able to apply the authorization logic. And authorization filters fundamentally run the authorization framework inside ASP.NET Core. And we won't dive into that as a whole separate talk, but you basically could define policies and a bunch of other things which control what claim principles should be able to do what within your application. You can write your own authorization filters. I typically wouldn't recommend it. You should really be using the authorization system as it's been designed. And as I say, they won't even run necessarily if you're using newer versions of ASP.NET Core. These could, if they do get executed, return a forbidden response, so short circuit the MVC request pipeline. They don't pass it down to the rest of the MVC framework. But more commonly, they're just going to pass the request on. The next set of filters are resource filters. And these are, again, a legacy kind of filter system, but they used to be useful when we needed to do something, make a decision based on the endpoint that was going to get called. Because, of course, at this stage, MVC would have run its routing and understood what endpoint's going to get called, and these resource filters could then run. So as I say, again, these will now be typically less common, and I would recommend using endpoint-aware middleware instead to implement the same functionality. But the type of thing they would do, so inside MVC, they use this filter for applying the consumes attribute, for example. So if you put that consumes attribute on any of your action methods, the resource filters will run to determine, well, does this request coming in provide the supported content type and that kind of thing. So again, they're fairly legacy. They have the opportunity to short circuit the request as well. But more commonly, what they're going to do is pass the request on into the rest of the pipeline. And later on, when the response stage is kind of completed and the pipeline returns the response out, they do get a second opportunity as well to look at the response on this on-resource executed method. Now, while they're a bit legacy, just for completeness, I think it's worth seeing a demo because it does make filters as a concept a little bit more concrete. So what I've got here is, let me just check this is set up. Yeah. So I've got an authors controller here. And let's imagine I'm building a new section of my API. It's not really ready to be used, but I want people to be able to call it if they opt into preview. So the way I've designed this is I've created the controller. It's partially working, and I've added this filter here via an attribute to this controller. So any action method in this controller is going to use this filter. The filter itself we can look at is an attribute, but it's also an iResource filter. So this is one of those filters that we were talking about just on the diagram there. And we have our two methods, on resource executing and executed. We do nothing on the executed. We don't care on the way out. But on the way in, what we're going to do is try and access the headers of the request, try and parse out something with the name preview. And if it's there, see if its value can be converted to a bool. And if so, what is the value of that? And basically what we're saying is if the header can't be found, or the value is there, but it's false, we're going to return a not found result. So this code executes here, and we're short circuiting the pipeline. The way we do that is set the result on the resource executing context here. So as soon as the framework sees that this result has been set, it knows it doesn't need to run the rest of the filter pipeline or even process this through the action method because we've short circuited. But in all other cases where this if block doesn't match, then we're just going to accept the request in, and we're going to add a response header so that later when the response goes out, we've identified that this came through to a preview endpoint. So that's the fundamental code, and we've mapped this via the attribute method to our controller class. So if I now make a request to my endpoint, let's check my headers here. So I'm going to make a request to the authors endpoint without a header set. The request comes in, and you can see I immediately get a 404 not found because our filter ran and it short-circuited the pipeline. If I now enable my preview header and press send, now my action method's getting invoked, and that's because it passed through the filter let it go through, and so now it eventually ends up in my action method. And if I continue this on the response, we'll see my preview endpoint header has been written onto there. So as I say, this today could easily be done now with endpoint aware middleware by the same concepts, but it's something sort of useful to do in those cases. So the key difference if you're doing this with middleware is you'd still have an attribute you apply within your controllers and actions, but you would then look for that attribute on the metadata of the endpoint inside middleware. So you do get endpoint, if it's present, see if the metadata says it has that attribute that you're looking for, and if so, conditionally apply your middleware behavior there. So that's the kind of principle of that, and we'll kind of leave those there. As I say, they're a little bit legacy. For completeness, the next middleware in this pipeline is the next filter in this pipeline is middleware filters, and these are essentially just very specific resource filters. They are the same thing fundamentally, but what they do is allow you to register middleware that only affects certain endpoints. So normal middleware affects all requests and responses as it flows through. Of course, it can do conditional things. So if it's a GET request, it may or may not run that kind of thing, but it can't do anything based on where the request is going to end up, what endpoint is going to handle it. And middleware filters can run that middleware that way. So they have, again, the opportunity to short circuit the pipeline. To apply this, what you need to do is create a class that has a configure method. So this looks very much like a startup class, I think you'll see. The configure method accepts an application builder, and on there we can register one or more pieces of middleware. So this is that same structure that we need to define our middleware pipeline that's going to be used just in this one instance where we apply it. And then to register that, we use this middleware filter attribute, which takes a type, and that expresses that for anything in the author's controller, we want to enable response compression based on the middleware behavior. Again, you'd use endpoint routing and endpoint aware middleware today to apply the same logic. So I'm just showing you for completeness. You'll be pleased to know everything after this is a lot more applicable to ASP.NET Core today. So the next stage is that we're going to need that instance of a controller. So this is where the controller factory creates the controller. And then we're going to enter into the action invoker phase of kind of MVC's behavior. There's kind of a two-step flow here. So the first is to execute the action method, which returns that iAction result. And then the second phase later on is to execute the iAction result itself, which should render a response. So the first phase, before we can actually invoke the action method, though, is that we need to do model binding. And the reason this is important is if we have on our action method, if it accepts any arguments, we need to supply those from the request somehow. And model binding is the process that does that. So we have a series of model binders. ASP.NET Core includes, I think, 15 or 16 model binders to handle different types and different sort of parts of the framework. And we'll look at adding our own custom one in a moment. But let's have a look at where a default model binder might run. So in this example, we have two arguments here, a string and an integer. So these are, fundamentally, core types of the framework. They're not complex types in the framework. And so for this method to be invoked, we need to be able to supply those when we call search, and the framework invokes it for us. So it has to find these somewhere on the request. And the way it does that is through value providers. Value providers are basically things that know how to get data off of a request. So there's a value provider that can look at query strings, for example. There's a value provider that might look at the path, and you can write your own if you have specific requirements that don't match those, maybe off of headers, perhaps, I don't know. But in this case, we're saying, okay, let's imagine this request comes into us. The model binding system kicks in and says, okay, I need keyword. I need a keyword. I need it to be a string. Does any of the value providers I know of have this? And the query string value provider in this case could go, yeah, I have something called keyword and it's a string. So yeah, I'll give you that and you can inject that later on when you need it. We also have a requirement for a page size integer. Well, the value provider on the query string again sees something called page size. It will check that it can actually cast it to an integer. And in this case it can, so that will be used when this method gets invoked. So that's for kind of the simple kind of framework types. What about the more complex types? So here we've got a very common case where we're doing allowing a post because we want to receive a new book, and we've defined a model that represents the data of a book. It has an ID, it has a title, it has an ISBN number. So how is the model binding system going to provide an instance of book input model from a request? Well, it clearly can't do it necessarily from query string values, but what it could do is look at the body of the request coming in and see if it can take the body and make it into a book input model. And so that's done through input formatters. ASP.NET Core today uses by default a JSON input formatter, so it will try and take any JSON content on the request body. It will try and deserialize that into the type necessary to invoke the action method. And if it all works, it can give you that instance and the method gets called. Today that works using system.text.json. So from 3.1 onwards, system.text.json is the serializer that's being used, the new Microsoft serializer. You can switch back to JSON.NET, Newtonsoft JSON if you need to, but generally for performance, if you can stick with system text JSON, it's going to be a bit more performant. You can also register an XML formatter. So that exists, but it's just not registered and enabled by default. So if you have XML data, we can still use that today. You could also write your own input formatter, and this is another point of pluggability. If you have messages coming in with message pack or protobuf, or maybe you've devised your own binary serialization format that you tend to use, you could create a formatter that knows how to parse that and turn it into an object and register them with MVC. So let's take a quick look at model binding by creating our own custom model binder. Now, again, this is one of those things, it's a very powerful ability. You don't want to overuse it, but where there are specific cases for it, it can be quite useful. And I've got one where I think it's pretty useful. So for my books controller, I have this method down here, get by date range. And so what this is going to allow is searching for books within a date range. And I've defined what a date range is by creating my own type. And I've even gone as far as to make this an immutable struct. It's not completely, it doesn't implement iEquitable or iComparable, but it's a struct and it's immutable by design, which means that some serializers would have trouble constructing this. Now, might be less of an issue today with system.text.json has kind of got a bit better. I haven't tested to see if it can handle it by default. But in this case, it can only be created through the constructor. And we even contain some sort of value type logic here that says, well, for our date ranges, we only accept the start date being earlier than the end date. So that's our logic. Here's its properties, the start date and an end date. And as I say, those can't be changed once this is created. So how do we allow the model binding system to create this instance? It doesn't know by default necessarily. And so what I've done here is use the model binder attribute to say, for this type, use this model binder. And there's two ways of attaching model binders. This is the first. And just to be complete, if you don't own this type, so if this is in an assembly you don't own and you can't add this attribute, if you want to, in the startup class, you can register model binders here as well, setting them on the options, the MVC options. So we just insert a model binder provider, so not a model binder itself. I'm inserting at position 0, which says run before all of the built-in ones, basically. And the provider is a very simple implementation of iModel binder that says, okay, from the binding context, what's the model type that's trying to be bound? Is it a date range? Okay, yeah, I can hand back this custom binder for it. And basically all of the providers get asked in order if they can provide a model binder, and if they can, that gets then used. So if we go and look at the actual model binder, it's an iModel binder, and we get the binding context. I've commented all of this code because it is quite lengthy and a little bit specific, but so you can go and check this in your own time if you need to. I'll sort of step through it all here. So the first thing we're doing is we're going to say we're hard coding the names of the properties that we're looking for on the request. That's potentially not a great practice, but works for this scenario. And the first thing we do is say to the value provider system, can you get me a value for something called start date, and can you get one for the end date? At this stage, they return a result. If either of those results is none, it means no, I haven't got a value that has that name. And so in this situation, we can't finish building our object. So what we're going to do is we're going to add a model error to the model state, which is the kind of state that represents how model binding has flowed through the system. And we'll say, okay, for this date range type that we're trying to map, we couldn't find start date and an end date, or one or the other. And we set the result of this to failed, and we just return a completed task. So this is we can't find the values. If we have the values, then we're going to set them on the model state, and then we're going to access the first instance of each value. So it's possible on the query string we might get 2 start dates, for example. I'm cheating a little and just saying, well, the first of those is the one I want. And then I'm going to try and parse those values to see if they are valid dates, because it could be something called start date, but it could be just some other random string. So check the valid dates, and assuming both are, come in here and try and construct a date range by passing in start and end dates. And if we successfully do that, we'll add a success on the model binding, passing back the object that we've bound. So this is our bound instance. That could, of course, fail if the date range validation fails. So we catch that exception here, and we add a model binding error again and set to failed. Or if we reach down here where either of the strings, I should say, doesn't parse to a date, again, it's a failure result with a model error. So that's the high level idea behind this custom model binder. And as I say, I've applied that then on my books controller, on my date range type here, which is required by my books controller. So if I make a request to get a book by range with a start date and end date here, interesting, why am I getting a 400 on this? It looks like a valid date. I was messing with this earlier, so perhaps I've broken something. Oh, that's a shame. Give me 2 seconds. That looks valid. So, well, we've got time. Let's do a very quick live debugging. Let's see if we step through here what I've broken. This is the danger of updating. Why can't I? That's constant. Why did I update this to different code before the talk? Okay, so we've got results. We do have values. We set the model states. The start date is that 2018 to 2019. They are valid dates. Okay, this is interesting. So start date, end date. It's a valid date range. I think I know what I've done here. Yeah. Okay. What I was messing with was, for completeness, I was doing this, and what I should have done is do this inside the if statement. So it's flowing through and now setting a failed binding result. So let's quickly start that back up again, and see that hopefully that it works. So ASP.NET Core comes back. Okay. Let's make our request. We don't need to break on here anymore, hopefully. Yes, we've come through. We've actually hit the action method. So we have a date range, and that date range obviously represents the date that we'd expect. And the request can now kind of be executed and go through the rest of our system. So we've got this nice, if you're doing sort of DDD and you're doing sort of value types and things, this is a good way to perhaps handle those custom behaviors if the default serialization can't map from your JSON into your type, for example. So I'm going to continue that request, and you get a book back. Now, we did have that rule. So on our model binder, or on our date range, I should say, we did say that the the start date has to be before the end date. So if I set an invalid date here, you'll see that now our model binder has picked up this invalid data. It's returned a status code of 400, and we've not let the request in. So kind of useful that we can apply that kind of custom logic into our request there. So let's continue. Apologies for the hiccup with that demo. Next, then, after model binding is we're very nearly at the point where we can actually invoke the action method. But before we do that, we have another set of filters that run, and these are action filters. The key difference between these and any other filter that's come earlier is that these have access to the bound object if one is present, or the bound properties, I should say. So these have a final opportunity to make some decisions based on those. And we'll take a look at one in a moment. But again, these might short circuit the request, but more likely what they're going to do is they're going to run, then they're going to invoke the action method that calls our actual method on our controller. And then after that returns an iAction result, they get another opportunity to run again at that stage. So again, let's look at a little bit of a demo for where we might use action filters. So I've got, where's my action filter? Yeah, so it's here. So well, actually, let's look at where we're using it and then jump back there. So it's still on this get by date range method. We have an attribute here, which is applying my action filter. And what my reasoning is let's assume that a date range is valid if the start date is before the end date. But in our application, because we don't want to allow people to maybe query 10 years worth or 20 years worth of data, we have a rule that we only allow 2 years worth of data at a time. We could code that logic into our date range, which might be valid. But more likely what we want to do is say, well, in place, any date range is really valid regardless of how long it is. But our cross-cutting concern that we want to apply to one or more action methods is we want this additional behavior. So I've implemented this as an action filter. So this is an iAction filter. We have on action executing, we get another context here. And what I'm going to do is say, give me the action arguments and try and get a value called date range, or for the item called date range. And if you get that value back, is it a date range type? Just cross-checking that it is. And if it is, we can now run some additional code against that and say our date range has to be in this 2-year window. And if it fails that test here, we're just going to set a bound request object result. So this means we're going to return a 400 to the user. And in this case, we want to include an object. So we want to include a body on the response, which in this case is a little bit adjacent, validating, or in this validation problem details format. So that's our kind of custom behavior here. And if I was doing this in one action method, I would write this probably in the action method. But if we want this same limit on 2-year filtering across other places where date range is used, then we can write it as this action filter, which means we write and test our code once, and we can apply it to any controllers or actions or the entire application if we want to, which is quite a nice way then of doing that. So to see this in action, if I adjust my date range here, so let's change this to say start of 2015, go to 2019. It's a valid date range from the perspective of start date and end dates. But when I run my request, you can see it's failed our checking this iAction filter. And if I continue, we get that 400 result and our sort of body here that we serialize. So we haven't run the action method. We've actually filtered this away from that by adding this additional logic in. You'll be pleased to know we're getting close to the end. So after action filters, there's 2 others that I want to talk about. So one possibility that is our action method runs, but somewhere in there, an exception is thrown that we don't handle. And the way MVC deals with this in the first instance is to run exception filters in the case that an exception has been thrown. So these get access to information about the exception and can do something with it. So for example, they might write out a 500 response with the stack trace and the exception details attached to it that later on middleware might kind of form into a developer exception page, that kind of thing. But what the key thing is that we don't blow up the MVC pipeline. We want to handle the exception in some form, but attach it to the context so further downstream it can be used. But we can write our own exception filters if we have additional exception logic that we want to run. And so again, I have another short demo for this one. So in my application, this time on my books controller, I have this additional method which just throws an exception, and then I want to handle this. So in my application, I have a global concept of how I want to handle requests. So what I've done is created a handle exception filter and registered it with the global filters of MVC. So this is all of the filters that MVC knows about are registered here, and any registered globally apply to all actions, all controllers. So inside this one, we can look at the code. You can see I can inject dependencies. And what I'm doing is here is when the exception's thrown, I'm using my iMetric recorder, something that knows how to deal with recording to our monitoring system, details about an exception, which we record. And then we return a custom JSON response. So we can further customize the result if we want to. And again, I'm doing this even conditionally based on whether in production or not. The key thing here is if you think about the power of this, instead of having to remember in all of our action methods that if an exception is thrown by putting it in a try catch that we want to call our monitoring system, we've written this now in a single cross-cutting concern way and applying it to our entire application. So any application exceptions that are thrown, we can alert on in our monitoring system and go and investigate. This is something you could also probably implement as middleware as well. It's kind of your choice where you do it. I quite like doing it here because these filters were specifically designed for the purpose. So if I hit my endpoint that goes bang, not too exciting, the exception gets thrown and we get our custom message. And of course, our monitoring system, if that was a real metric recording system, will be notified of the failure. So that's kind of exception filters in a nutshell. So the final one then that runs in this context of MVC is result filters. So these are very similar again to action filters. The only additional information they have at this stage is because the action's now been invoked, they have the iAction result that action method should have returned. And so we can do some additional work and additional sort of conditional behavior based on knowing what the iAction result is before an action result gets executed and turned into the response, because this is our last chance really before a response body may be written to the request. And after we start writing the response, we can't add headers. So I've got an example of this in a moment where we'll see why that might be useful. But normally what happens is those run, the iAction result then gets executed. And typically in the case of an API, this will call into the JSON output formatter. So again, like input formatters, we have different output formatters that we can register that say for this content type, use this formatter. And that's the thing that then will use a JSON serializer, in this case, system text JSON, to render the body, the JSON sort of body that's going to go out. Again, you can switch back to Newtonsoft JSON. You can register the XML one that Microsoft provide if you need that, or you could have your own output formatters, again, if you've got different output types you want to produce. So that formatter runs and produces basically the final response that's going to go onto the HTTP context. And at this stage, the pipeline is complete. So the pipeline kind of passes back through a few of those filters that have a second chance to see the response before it goes out. But fundamentally, the pipeline's complete. So let's have a look at the demo for this one, which is the last demo we have. So in this scenario, I've got a situation where I've got this result filter. I've derived from result filter attribute, which itself is an attribute and an iResult filter. And I've said on here, I'm going to do a very basic behavior. So if the result, the iAction result this is, if its result type is, or its type is an OK object result, which is just one of many implementations of iAction result that the framework might return. An OK object result is basically saying we're going to return at some stage of 200, and it's got an object that will essentially be the body of the response. I've got some kind of pattern matching going on here. So what I'm saying is, if it is an OK object result, check if its value is also of type mutable output model base, and if so, we'll do something with that. So this type is just a custom base class I've defined, and what this does is define that we might have a last modified date. This is then used on my book output model, derives from this. And so these are all the details about a book, but I've decided in this system at least that anything that could be mutated in the database, we're going to represent it as also a mutable output model base type, which contains the date from the database of when it was last modified. Many ways you could do this. This is probably over-engineered for this scenario, but illustrates the point. So we have our model, we have our type here, and in our filter, what we're saying is if that matches, if it does have an object that derives from this, on the response, we're going to set the last modified date header before the response body is written. We're going to set this header with the value from that object. So not too exciting. And again, this one's registered as a global filter, so to all requests. So if I make a request here for a book, get the response back, you'll see my serialized model includes my last modified date, which is obviously part of the type. But because my header has been added on here, I've now added my last modified header on as well. And there's various ways you could set that. But imagine you have custom headers or things like that that you want to set conditionally based on properties of the iAction results object. This is maybe a way that you could look at doing that kind of behavior. So doing on time, pretty much there. So we've concluded the MVC part of this pipeline. That passes the HTTP context back to middleware. And again, last time I will remind you of this point, middleware then gets called and invoked in the reverse order as the response goes out. So each of these pieces of middleware can look at that HTTP context and see the response and determine if they might want to do something based on it. They could even entirely change the response if they needed to for some reason. That's perfectly possible here. The middleware passes back at this stage back into Kestrel, back into the iServer, and Kestrel takes that HTTP context and now needs to convert it back into the bytes that represent a HTTP response. So here I've included the response. I haven't included all of the new lines on this example, but this is what a response looks like. It's, again, a bunch of ASCII text with, in this case, UTF-8 JSON payload. So the status line here says, okay, this is a HTTP 1.1 response. The status code is 200. The status reason is okay. I have some headers. Some of these have been set by ASP.NET Core and MVC. Some of them, as you can see there, with the server header, for example, is set by Kestrel. And then we have our custom last modified header that we added on as well. We have our response body. This was produced by the output formatter, the JSON output formatter. And now we have this response. And those bytes get sent back down to the client who has now completed a request. So we've kind of gone end to end on the request cycle there. So just to quickly summarize, before we go to questions, the HTTP request is received and parsed by Kestrel. So ASP.NET Core is hosted within this kind of hosting concept, which runs an iServer. Kestrel is the default iServer implementation. It takes the request bytes, turns them into a HTTP context, and then passes them down onto whatever implements HTTP application. That's kind of ASP.NET Core fundamentally. That goes through a middleware pipeline. The middleware pipeline can inspect that context. They can short circuit the request and return a response. They can pass it on unaltered to the next middleware, or they can adjust it and pass it on to the next middleware. All of those are possible things they might do. And then finally, in this scenario, we've looked at how that then entered into ASP.NET Core MVC, which handles the request. We have the filter pipeline that runs. That eventually leads us to execute the action method that we've got on our controller. So in some applications, that action method could be the very first piece of code that we've written that gets run, but it's all the way behind all of those layers that run before it. That returns an iAction result. The iAction result then gets executed at some stage to return an actual method, actual HTTP response. And so that's pretty much the end-to-end picture of what we looked at. So thank you very much for your time this evening. I hope that was what people kind of joined and were looking for. Again, if you have questions later on, or you're just interested in following my stuff about .NET, you can find me at Steve J. Gordon on Twitter, my blog, stevejgordon.co.uk, and as George mentioned, I've got 5 Pluralsight courses out if you want to go and check any of those out. Most of them are on ASP.NET Core and microservices and dependency injection, that kind of stuff. And a final reminder, there's a bit.ly link if you want to go and look at these slides and look at them later, or if you want to pull down the code, bit.ly/ASP.NET anatomy. So that's it from me in terms of what I wanted to share with you. So I'm going to try and bring up my chat window here, I've lost the chat window. Where's chat? Okay, I'm going to do old school. I'm going to look at the chat on my other device.
I can also pass you some questions if it's better for you.
Yeah, let's go for that.
Well, there is a question, at least I will start the other way around, from Trimmer. Forgive me if I'm pronouncing names incorrectly, right? So first of all, he finds it or she very, very interesting, as I do, and he asks if the what's the VS font, by the way? So it's kind of
yeah. So the font, if I bring up a web browser, is called Veracode. So find the web page here. So you can find it here on this link. I'll post this into the chat when I can find the window in a moment. But yes, it's Veracode. It's got these kind of nice ligatures and things on there. I really like it for you know, you get these nice kind of lambda arrows and stuff.
Yeah, very nice. Very nice.
That's pretty much the first question that I always get asked after this session, actually, is what's the font? Everyone needs to know.
Yeah. It's the first question, right? Yeah. So there's another question by Sergi. I'm trying to understand what Kestrel unable to do, why especially we need IIS, probably Kestrel, and why we need IIS and not Kestrel. I'm not sure I understand the question correctly. Is there any limitation there?
Yeah, so if I'll choose to interpret that as basically, is there anything Kestrel can't do? Is there any reason why you wouldn't use it, I guess? Do correct us if we haven't understood. So Kestrel is a fully feature-rich web server these days. So as I say, in the 1.0 days, it wasn't certified as edge-ready, which meant Microsoft hadn't battle-tested and hardened it to ensure that it couldn't be sort of compromised. So they always recommended in 1.0 that you put it behind either IIS or some other reverse proxy when you were doing sort of ASP.NET Core applications. But I think since 2.0 or maybe 2.1, they basically did all of the work that they needed to do to kind of harden it, battle test it, make sure that people couldn't compromise it by DDoSing it too easily. And so now it is certified. If you want to run it, open to the internet, you can do so. I would still recommend generally securing it behind, reverse proxies. And if you're running in the cloud these days, you're almost certainly going to have load balancers and reverse proxies and things in the way between the two. But I would always choose it over something like IIS, mainly because of the cross-platform. So for us, we run, when I worked in my old job, I should say, we ran all of our services as Docker containers. We ran them on the Linux sort of Debian, which meant obviously lower cost, lower footprint. And because then we could run the web server directly as just a standard, ASP.NET Core .NET process, we didn't need to worry about adding any web servers into the mix. If you're still on Windows and you still have reasons to be behind IIS, that's supported. They've got a good interop between the two that you can use as well.
Cool. Yeah. Well, Rafael mentions here that the code of this presentation is available on your GitHub account for everyone. That's a nice thing to know. There is a question by NASA. Would you please tell us why responsibility of OWIN in ASP.NET Core and of course in ASP Web API 2? What? Sorry, I'm trying to read and understand at the same time, and sometimes it's does it work as pipeline injection, and if it is, why we need it in ASP.NET Core?
Okay, I think I think I understand the intent there. So OWIN is an ASP.NET thing. From OWIN, the team used the concepts from OWIN to build ASP.NET Core with the middleware pipeline and things in there. So ASP.NET Core isn't using OWIN. It uses some of the patterns, the ideas of like middleware that OWIN introduced, but it is its own, newly written thing. So there's no OWIN in ASP.NET Core. It's just the middleware and everything that's part of ASP.NET Core baked in. OEM was kind of, I guess, the stepping stone. So, you know, moving from older ways of doing ASP.NET Core applications, it gave you the opportunity to add that kind of middleware handling of requests into ASP.NET at the time, and was kind of like a transition point, I guess. And you can almost see that as Microsoft, you know, testing the waters by building this kind of OEM compliant implementation, and then later, you know, deciding that that was how they were going to completely re-architect what became ASP.NET Core.
Yep. Yep. Another one just came in from Leandro. Sorry. I'm sorry, Leandro. So he asks that if he wants a simpler but more performant MVC pipeline, is there an alternative recommended of ASP.NET MVC? Or do you think that MVC is the best and lightweight service available out there?
Yeah. First point is MVC, ASP.NET Core, the whole thing, a lot of work has gone into performance generally. So the team have tried to do a lot so that MVC is a performant, you know, design pattern on top of what is kind of fundamentally ASP.NET Core and Kestrel. And so for a lot of situations, you know, using MVC isn't going to introduce a huge amount of overhead for you. What you can do, so hopefully my code's still showing here. So I've, in this application, chosen to map controllers, which essentially says I'm going to use MVC and I'm going to use its controller system. We don't have to do that. So we don't have to be using MVC at all in this application if we don't want to. We could implement all of our logic as one of two ways, really. Middleware, which I've done in the past. So I've written, in my previous job, again, I wrote some services that were meant to be, you know, handling many, you know, hundreds of thousands of requests a second. They needed to be very performant, very low latency. And so I didn't want any additional overhead in the pipeline. So I wanted basically Kestrel and then middleware. And that's all I had. So my middleware passed, you know, read through the HTTP context, established what it was going to do, built a response and added it onto the context. And you can do that with middleware only code. And at that point, you've taken out all of that MVC filter pipeline, all of the logic that's running. And so you are going to improve both, you know, the latency slightly, and also going to reduce, you know, it doesn't have to instantiate a controller. So there's, you know, there's less garbage collection and things going on as well. The other thing you can do today is what Ryan Nowak, who is was one of the ASP.NET team, is you can actually build what he called routerware, or American term routerware. And that is basically where you could keep some of the functionality of what middleware provides and go one step further and basically add routes. So we can do endpoints dot map, and then in there we could say, well, for this path, you know, slash something, I want to do, I think it's just a request delegate. So I want to, yeah, access the request delegate. I think get the context. Was it? I can't remember the items. Oh, okay, there it is. It's on the request itself. So we can access the request. We could then, you know, read the body, do something with it, and return a response. So this is another way of kind of doing the same thing. You're not using MVC. You're using endpoint routing. And what we're really doing here is defining an endpoint that isn't an MVC endpoint, but is just our own custom thing. So this then gets, when the app starts up, this gets added to the route table. So anything that maps to this path will then invoke this code. And so that's another way of doing lightweight things. There are other frameworks that people have done. Trying to think of the name of it now. Yeah, there's a couple of other frameworks out there that people have written, which are trying to remove the, you know, the more maybe perhaps legacy MVC pattern from ASP.NET Core and provide their own thing. It's really pluggable. I mean, the only thing really that we're using inside ASP.NET Core at this stage is middleware until we decide if we want to use MVC down here. And arguably, you could write your own implementation of HTTP application, which is fundamentally what ASP.NET Core is, and the middleware pipeline gets executed in. So if you wanted to go really deep, And this is something I want to play around with someday, because I don't know what it looks like to do that. But you could write something that Kestrel immediately passes a context to, and then get really, cut out even the middleware layers in there as well. So lots of possibilities. I would say if you're just looking for something that is raw performance and it's fairly straightforward, maybe only has a couple of endpoints, using this endpoint approach here might be quite a good way to go. Or you could use middleware, but in there you then have to remember to check the path that's coming in, and this kind of does that for you. So that might be why it's better.
Well, there is 2 more questions. One from Amine, which it's at the beginning of the .NET learning path, let's say, although the questions might be a bit out of context, but he or she, forgive me, I don't know, asks if the Kestrel plays the role of the web server, then if the Kestrel is the web server, then who plays the role of the application server? I think there are some things a bit, I mean, you have confused a few things here, but I mean, Steve, do you care for a quick answer there?
Yeah, again, I think I get the gist of this. So I've brought up on screen one of my Pluralsight courses, which will touch on not exactly this question, but it touches on hosted services and worker services, which is another kind of pattern and part of kind of ASP.NET Core applications. And fundamentally, yeah, Kestrel is the web server. So this is the thing that binds to a port, listens on that port for bytes coming in from connections, and then creates or parses those requests into the context. What that's running inside of is what Microsoft call a host, an iHost. And the host is the thing that actually kind of keeps your application alive. So if I jump back to here and we just take a look at the program class, you'll see that all this application is at its core is a console app. So if you've done a Hello World console app, you'll know it has a main method. And in here, what this does is call into this thing that builds the host. So we configure the host in here, we then build it and then run it. And the host is basically the thing that keeps this console app and this process alive. So it's essentially a while true loop that's running in the background that basically listens for the shutdown of the application. So if someone signals that this, and again, when this is running, it's just a console app. So if I'm running this application and I control C into here, that signal is picked up and then maps to shut down the actual process. So it's the iHost that's kind of fired up that keeps your application alive. And then within that, the iHost starts up or can register, as we're doing here. Well, we're doing it within this create default builder stuff. So let's see if I can navigate into this. But inside here, no, I don't have the code I need. Inside there, it's basically registering Kestrel as the web server, and then Kestrel's kind of binding to ports and doing the rest. I hope that answers the question. Again, if you have further stuff on that, I do have some articles on my blog about kind of how the host framework works. And if you do have Pluralsight, then that course will give you a bit more of a kind of in-depth answer.
Yeah, it will definitely help. One last question, I think, from Nazar. It might be a bit just of course here, but anyway, it's about Blazor. So he's asking that what we've seen here is capable of handling hundreds, millions, and huge number of requests. He asks if you are aware if Blazor server side is also similarly reliable in handling such a big number of requests.
In principle, yes. So I've not used Blazor in anger. I've played around with it in the early days. So you'll probably find more information on this on the release notes and the blog post that Microsoft did. But Blazor server side is pretty much exactly the same as what we've got here. But it is using a kind of a WebSocket behind the scenes to send the diff between the client DOM and your web server back and forth. But it's doing the kind of rendering server side. So the additional thing that it adds is that you do need a signal R connection between client and server for that to run. And so scaling that can be a bit more of a challenge, I believe. In Azure, they do have a SignalR as a service. I suspect for scale, you'd probably want to use something like that. So they manage the backplane and all of the WebSocket connections, but they maintain a pipe to your application to kind of pass that off to you. And I think that's probably the recommended way of scaling that kind of stuff at huge scale, because otherwise you need a huge number of, support for all of those running WebSockets, which, do hold resource in your application. So I can't say much more than that, but you might want to check. There's a guy named Chris Sainty, who's on Twitter. I'll see if I can find him while we're talking. But he is he's basically kind of a Blazor expert. So you might be able to approach him or check out his blog posts. Here's the guy. Check out his blog posts, and he's working on this book now. So you might want to go and take a look at buying this book potentially as well from Manning, which kind of covers Blazor in a great deal of depth.
Well, very well. I think the next part is mostly a request that we both can take on. At least our user group for sure can take on. I mean, Blazor server side or not Blazor in any way, it's one of the focus this year. So at least for our user group, we will for sure try to have more Blazor. I don't know, Steve, if you also prepare some sort of talk about Blazor.
I haven't yet. It's one of those technologies that's on my list, but at this stage, I would not be able to talk much to it. But what I could do is, certainly offline, George, we can maybe get you in touch with Chris, and he's a fellow MVP, as I say. He's writing the book on it. So I've seen a couple of his sessions on Blazor. Both are kind of a beginner one, and then a bit more like how does it work internally. And both of those are really good. They may be online on YouTube as well. I think he's done them at NDC. So NDC conferences might have the videos as well if you want to get to them quicker.
Perfect. That would be super. Yep. Perfect. I think there are no more questions, right? It was very fun. Very. We all learned a lot of things today. I really hope we can redo this sometime in the future, Steve. It was a great pleasure having you here.
Pleasure to come along.
Everyone, thank you very much for seeing this event, for being here. Happy New Year again. We all hope that it will be a much better year than the one that we gladly left behind. We hope that such a nice meetup, such an interesting event for the first event of the year would just open the path for much better in the future. So thank you very much for being here. Have a nice evening, a nice year, and see you in a few days.
Thanks, everyone.
Ciao. Bye.